As data grows more important in today's society, almost everyone has come across phrases like data science, machine learning, artificial intelligence, deep learning, and data mining. But, exactly, what do these phrases imply? What are the distinctions and connections between them? While the terms above are all related, they cannot be used interchangeably. This article will help you understand not only what studies and expertise help extract knowledge from data to make machines more intelligent, but also how they do it. Whether you're a specialist interested in data-driven research, a business owner eager to make the most of modern technology, or just someone who wants to be more tech-savvy, this article will help you understand not only what studies and expertise help extract knowledge from data to make machines more intelligent, but how they do it. In a nutshell, all data disciplines. The most popular words are data science, data mining, machine learning, deep learning, and artificial intelligence. So, before we get into the details, let's take a brief look at all of the data-driven disciplines. The wide scientific study of making sense of data is known as data science. Consider recommendation systems, which give clients with individualized ideas based on their search history. If one client is looking for a rod and a lure while the other is looking for a fishing line in addition to the other items, the first customer is likely to be interested in buying a fishing line. Data science is a wide term that encompasses all activities and technology that aid in the development of such systems, including the ones we'll describe here. The data science pipeline frequently includes data mining. Data mining, on the other hand, is primarily about the processes and tools used to uncover previously unknown patterns in data and make it more valuable for study. To return to the example of fishing supplies, data mining entails analyzing the previous 2 years of data to uncover connections between the number of sales of fishing rods in different states before and during fishing seasons. Machine learning tries to train computers on historical data so that they can process new inputs based on learned patterns without the need for explicit programming, or explicitly spelled out instructions for a system to do an action. The recommendation engines we discussed before would be out of reach if it weren't for machine learning, because it's tough for a person to go through millions of search queries, likes, and reviews to figure out which clients buy rods with lures and which buy fishing line on top of that. Deep learning is the most popular field of machine learning, and it employs complicated deep neural network algorithms that are inspired by how the human brain functions. Without being informed specific data qualities to look at, DL models may produce reliable results from enormous amounts of input data. Assume you need to figure out which fishing rods result in favorable internet reviews and which ones result in bad ones. Deep neural networks may be used to extract significant attributes from reviews and perform sentiment analysis in this scenario. Artificial intelligence is a vast subject. But, for the purpose of simplicity, consider any real-world data product to be AI. Let's stick with the fishing theme for a moment. You want to buy a specific model of fishing rod, but all you have is a picture of it and no idea what brand it is. An AI system is a piece of software that analyzes your appearance and suggests product names and stores where you may buy them. You'll need to employ data mining, machine learning, and perhaps deep learning to create an AI product. So, let's go through everything again. Data science has a broader use. It's a discipline similar to computer science or applied mathematics. Inside a data science process, data mining is mainly about tightly focused approaches, but pattern recognition, statistical analysis, and creating data flows are relevant to both. Data science, and hence data mining, may be used to provide the knowledge foundation required for machine learning, deep learning, and artificial intelligence. With this summary, we'll move on to more detailed explanations of words as well as how they connect to one another. What is the definition of data science? Professor Vasant Dar of the Stern School of Business provided the following definition. Data science is the study of generalizable information extraction from data. Although it is one of the most widely cited definitions of data science, it needs a more thorough explanation. Data science is an ever-evolving scientific subject that tries to comprehend data, both organized and unstructured, and find insights within it. Machine learning, AI, deep learning, and data mining are examples of data science techniques that use huge data with a variety of research, methods, technologies, and tools. Data analysis, statistics, mathematics, and programming, as well as data visualization and interpretation, are heavily used in this scientific subject. Everything discussed above assists data scientists in making well-informed judgments based on data and determining how to extract value and useful business insights from it. Process and applications of data science. To make sense of massive volumes of data, data scientists work with it. Data scientists may gather, analyze, and analyze data using the correct data analytics tools to generate conclusions and predictions based on uncovered insights. What is data mining exactly? Data mining is a collection of techniques and tools that scientists and researchers use to extract new and potentially illuminating information from enormous volumes of previously unknown data and convert it into consumable structures for future use. The notion of identifying hidden patterns and anomalies that indicate the multidimensional relationships in raw data is at the heart of contemporary data mining tools. Process and applications of data mining. The data mining process is divided into two parts: data preprocessing and real data mining. Data purification, data integration, and data transformation are all part of the first, but data mining is all about pattern recognition and knowledge representation of data in an easy-to-understand manner. Data mining is frequently considered a subset of the larger discipline of knowledge discovery in databases, or KDD. Data mining's practical applicability is not limited since its approaches are applicable to every industry that interacts with data. But, first and foremost, data mining methodologies are used by enterprises launching data warehousing initiatives. The study of shopping cart similarities, for example, is commonly used in e-commerce and retail to find goods that customers frequently purchase together. What is machine learning, and how does it work? Machine learning is a collection of approaches, tools, and computer algorithms for teaching machines to evaluate, comprehend, and anticipate hidden patterns in data. Machine learning's ultimate objective is to use data for self-learning, removing the need to instruct machines explicitly. Machines that have been trained on datasets can apply learned patterns to fresh data and so generate better predictions. There are several forms of machine learning. In supervised learning, machines are taught to solve problems with the help of people who gather and identify data before feeding it to the systems. A computer is given specific data features to look at so that it may identify patterns, classify things, and assess whether its prediction is correct or incorrect. Machines learn to spot patterns and trends in unlabeled training data without being supervised by humans in unsupervised learning. Models are trained with a small volume of labeled data and a considerably larger volume of unlabeled data in semi-supervised learning, which combines supervised and unsupervised learning. In reinforcement learning, models are placed in a confined environment that is novel to them and must solve a problem through a series of trials and mistakes. Machines are punished for errors and rewarded for successful trials, similar to a setup scene in many games. They learn to find the best answer this way. Use cases and the machine learning method. We'll use spam email filtering as an example to demonstrate how machine learning works. So, if you go to your email account's spam folder, you can encounter a jumble of messed up and irritating messages. Spam detection systems assist users in separating irrelevant communications from those that are essential to them. The Naive-Bayes algorithm, which predicts the likelihood of occurrences or results based on previous information, is a popular way for training a model. Some characteristics are associated with spam communications, while others are associated with authentic email. Words or phrases present in the email body and header are the features. The program then calculates the likelihood that an incoming message is spam. You already know that a message labeled "You won $1 million" is most certainly spam, but a machine must learn this first. As the model learns the patterns, it will be able to appropriately assign a score to each new email. Passing scores are delivered to the inbox, while scores below a specified level are discarded. People manually designate certain inbox messages as spam while using email services, contributing additional data to the system's training data set. Model retraining is a step in the machine learning pipeline that guarantees a system stays current and produces reliable results. Medical apps that analyze patients' electronic medical data and claims to forecast which patients are most likely to become ill or other notable machine learning examples. Machine learning-based fraud detection systems are another outstanding example. They assist in the detection of potential scams by monitoring questionable user activity.